So what we're going to learn today is the root test, and we have the root test and the ratio test are our only two tests left for determining if a series converges or diverges. They're both going to have similar type of conclusions. So what we do with the root tests is we take a series, we take the nth root of the terms, of the absolute value of the terms, and we compute that limit, which is a really weird thing to do, but that's okay, that's what we do. When we do the ratio test next class, we're just going to compute something different here, but this conclusion is going to be the same. So at least we don't have to memorize too much. So if that limit is less than 1, then the series is absolutely convergent. So remember that absolutely convergent was just that stronger version of convergence that we learned last time. If L is bigger than 1, that limit is bigger than 1, the series is divergent. And sadly, if we get 1, we don't know anything. And so we have to try something else, maybe like the alternating series test or something. So let's see what happens here. This test is going to be useful in cases like this one here, where we have like an n in the exponent, so that taking the nth root will actually be useful. So let me show you what happens here. So let's do our work up here. So let's take the limit as n approaches infinity. I'm going to take the nth root of this whole thing. And don't forget the absolute values. Those absolute values are important. Your final answer should always be positive with these problems. Okay, so when I take the nth root of something raised to the nth power, the nth root and the nth power cancel out. So like this root and that power are going to go away, which is good, because I'm left with 5n minus 3n cubed over 7n cubed plus 2, all in absolute values. And as approaching infinity, you could do L'Hopital's rule here. We could also just say, let's take the highest power from the numerator and denominator. So we're going to keep this guy and this guy. The absolute values do end up coming in handy here. So I'm going to have negative 3n cubed over 7n cubed, which simplifies to 3 over 7, negative 3 over 7, but the absolute values make that positive. So we get 3/7. 3/7 is less than 1. So our test tells us that the series is absolutely convergent. So we'll say absolutely convergent by the root test. And absolutely convergent also means convergent. So this series is also convergent. So we'll just do this one example in today's video and we'll get lots of examples in class.